Hi everyone, I hope you had a good day off on Wednesday. I know that it's a little bit difficult to catch up without the lecture and the tute and everything, and we sort of missed all of it at once. Further, I think there's been problems with the iLecture. It's probably best just to go through the PowerPoint of the lecture slides and work out where you need help. So I'm just going to do one more example on solving an equation where we've got two expressions and they're both linear. So what we mean by linear with algebraic expressions is that if we look at the variable, so in this case it's x, the coefficient of x, we just have a coefficient of x, in this case 4, in this case -2, and x isn't squared or doesn't have any other more complicated function associated with it. The other reason, the main reason why it's called linear is because if we plot these on Cartesian coordinates, so these are my axes, I'll just go rough in things of 10 so I can fit everything on. So this 4x plus 3 equation would intercept this axis about here, and it's got a gradient of 4, so we'll say, alright, it'll look, something like that. It should just be a straight line. And then this -7 minus 2x, on the other hand, will intercept the axis here. These intercepts, by the way, are just where that extra number is, because on this line here, x is equal to 0. So in this case, when just looking at this side of the equation, when x is 0, we'll have -7, and then it's going down at a rate of -2x, which is not as steep as this. It's about half as steep as that, so it's more likely going to be something like this. So we can see just from drawing in the graph that our answer should be somewhere around here. So we should get a value of x that's, -1 or something, and a value of y that's around -5. But let's see whether we get that. Now, if you're good at solving normal equations, so when we've just got a linear expression on this side and a number on this side, there's just one extra step we need to do when we've got two linear statements on either side. And that's get x to one side. So, for instance, if we have, something like 3x plus 1 equals 2, a statement like this, if we can deal with that, the only difference between this and this statement is that this one's got x on both sides. So that's what we're going to try and get rid of. And we do that in the same way that we get rid of, it's called getting rid of, but what we're really doing is applying inverse operations so that they cancel out one another and we can isolate different parts of the equation that we want to get to. So in this case, I've got 4x on this side, I've got -2x on this side. I want x only on one side, so I can either take the 4x away from this side, or I can get rid of the -2x from this side. And it doesn't actually matter which one I do. But how we usually tend to work is sometimes we prefer to get everything on the left-hand side because we like doing it that way, or sometimes because this is a -2x, I don't like dealing with negative numbers, so I'll get rid of that one. So what it means to get rid of something, well, basically I want to get back to that identity. So remember that the identity for addition is 0, because 0 plus anything is always just equal to that thing. Could be 3, could be 2, or whatever. So I want to, find out the inverse operation I apply to this -2x in order to get to 0. And it doesn't matter what x is, as long as x is some number, which it has to be in this case. But if I subtract 2 of those x's, clearly to get to 0, I need to add 2 of those x's. So you can think of this, maybe even on a number line. We don't know how big these statements are, but this must be x and this must be 2x. So basically I've gone back step of x each time, and to get back to this 0 point, I need to reverse that process. So I'm going to add x to both sides. And usually I set it out like this. I say, okay, I'm going to add 2x, add 2x. I have to do it to both sides so that this equality still holds. So I'm going to add 2x to both sides. I can rewrite everything out as it is here. On this side of the equation, I'm going to group the like terms together now, so I can add 4x and 2x. 4 times a number plus 2 times a number will give me 6 times a number. And then I can add the 3. And you might notice, if you paid a lot of attention to the group theory video or the triangle symmetries video, you know, in order to do this, I need to actually be able to move the 2x into here and sort of group them together. So actually, you know, this is a reasonably simple step because we're using it, but actually I need that associativity and commutativity in order to do that. So it's not exactly trivial. On this side I've got -7 here, and then when I group these together I've got -2x plus 2x, I get 0, so it essentially vanishes. So sometimes we refer to this as sort of, it's like moving the 2x to the other side. It's not really, because you know, we don't actually move things around as such. It's just that I applied an operation on this side that made this 2 cancel out, this 2x cancel out. And so, you know, I chose it carefully, and then I get 7 by itself. And now we're in a position where we can just solve as we can for linear functions. So I will keep doing it. Sometimes I stop and say, you can do it from here, but why not? Let's just keep going. So now I want to get x by itself. I want to know what x is. So in order to do that, I now need to get rid of this 3 first. I could get rid of the 6, but because the 3 is in the way, I'd need to divide this whole equation by 6, and then I'd be left with a funny factor on this side. You might like to do that as an alternative way. Try dividing both sides by 6 first. You still should be able to solve the equation. But I'm going to do the 3, just because it's easier. So again, since I've added 3 here, the inverse operation is subtracting 3, and I need to do that to both sides. Once I do that, I get 6x plus 3 minus 3 equals -7 minus 3. These will cancel out because plus 3 minus 3 is 0, so I get 6x equals, and then on this side I've got -7 minus 3, I'll get -10. And then my last step will be to divide by 6. So since this is 6 times x, or x times 6, could be in either way, I need to divide by 6 on both sides. So on this side, if I divide by 6, I get 6x. Oh, sorry, I'll need to move it up to here. So at this stage, I have 6x over 6 equals -10 on 6. And because this 6 times x over 6, or I could also think of it as 6 times x times 1 on 6 is the same thing, equals -10 on 6. And so here, when I multiply 6 and a sixth, I get 1, so I get that x here. That's why I chose the division by 6 in the first place. And here I say this is, I can simplify it a little bit, -5 on 3, which is what it should have been in the first place. Remember, we saw it on the axes, it was over on this side. Okay, I hope that helps as an example. There's plenty of examples of this available on the internet, and your last step, if you want to check your answer, is just sub this value here back into the original equation. And if it doesn't work, then something's gone wrong at some point. Okay, I hope you have a good weekend. Bye.